Hey everybody, Mr. Klinkerman here. Alright, we're in section 2.7 still, and we just got done learning about how to prove statements about angle pair relationships, and in particular we learned some theorems and postulates, the linear pair postulate, along with the congruent complements theorem, congruent supplements theorem, and the vertical angles theorem, among others, and the right angle congruence theorem. Alright, now we're going to learn how to apply some of those theorems and postulates, or in other words, angle pair relationships demonstrated by those postulates, to find missing angle measures, also to identify congruent angles and so forth. Alright, so we're applying the theorems and postulates that we've learned in this section. And in these first couple of slides, what I'm going to want you to do is this. I'm going to want you to identify the pair or pairs of congruent angles, if there are more than one, that are in each figure, and we're going to explain how we know that they're congruent. Okay, now again, we just learned several theorems. I'm going to speak them out loud right now. If you need to jot them down, do so. We learned the right angles congruence theorem, the congruent supplements theorem, and the congruent complements theorem, along with the linear pair postulate and the vertical angles theorem. Alright, now we're using those things to determine, are there any congruent angles in this picture. Pause the video. See if you can find any congruent angles and think about why they're congruent. Alright, then unpause and I'll share with you the angles that are congruent here and what the reasoning is, and we'll see if we'll match up that way. Alright, one thing I ought to mention is that we're not going to bother mentioning straight angles here, because straight angles are always congruent to one another, and while that's true, it's not usually useful. Alright, so ignore straight angles, but here's a pair of congruent angles, for instance. And probably the easiest one in this picture, I told you that these two angles there were 25 degrees, and so of course they're congruent since their measures are equal. Or you could say by definition of congruent angles. Alright, are there any more pairs of congruent angles here? Well, yes, actually. And let's see if you got these and if you got the correct reasoning for it. Turns out the angle KAN is congruent to angle BNA. Alright, let's make sure you see where I'm talking about. Angle KAN right here, and angle BNA right here. I'm going to mark those as congruent in the picture this way. And why are those congruent to one another? Well, each of those forms a linear pair with a 25-degree angle, right? These are linear pairs. These are linear pairs. Each linear pair has a 25-degree angle, so that means the other angle in each linear pair is going to have to be 155 degrees. These two angles are congruent because they're supplementary to congruent angles. Alright? So I can write that out, since they're supplementary to congruent angles. Okay, or I could have named the theorem that justifies that, which is the congruent supplements theorem. Alright, making sense so far? There we go. We use the definition of congruent angles and the congruent supplements theorem to prove that there were some congruent angles in that figure. Here's a whole new figure for us to work with. Alright, and there are a ton of angles here that are congruent to one another. See if you can find some pairs and, well, justify why they're congruent. Alright, here are some angle pairs that are congruent. One of them is angle MXA and angle BXN. Alright, those are both right angles, aren't they? And we've got that nice right angle congruence theorem that says that right angles are congruent. So that's going to be my reasoning as to why those are congruent. Alright, another pair of congruent angles are these. And why would angle MXB here be congruent to angle AXN here? Well, they both form a right angle with angle BXA. Alright, let me mark the two angles that we're talking about. This angle and this angle are congruent. And they're congruent to one another because they're both complementary to the same angle right here. So you can say the congruent complements theorem, or if you want to write out a reason, this would be it. Alright, I'm going to list one more pair of congruent angles, although there are several more that you can mention. Here's the last pair that I want to talk about though. And why you might wonder would angles KXF and BXA be congruent to one another. Alright, well let's look where they are. Here's angle KXF. Here's angle BXA. Hey, look what kind of pair of angles those are. Those are vertical angles, aren't they? Alright, so this angle and this angle are going to be congruent to one another because vertical angles are congruent. Alright, I hope you're getting the idea of how you use these theorems and postulates within this section. I want to do one more example within these notes. It's a relatively short video for you right here. And in this next figure, what I'd like you to do is simply define the values of the variables. Okay? Now, I'm not going to say anything other than you should look for some special kinds of angle pairs within this picture, and then make the equations that involve the relationships between those specific types of angle pairs. Alright, pause, try to find them on your own first, watch to make sure you did it right, of course. Alright, so here's how the solution is going to go. First, let's find the value of x. Alright, just going alphabetically because, hey, I feel like going alphabetically. And what I hope you notice there is that this x, the angle that's x degrees, is complementary to this 17-degree angle, right? Because together they form angle NKG, which is the right angle. Alright, so they're complementary. And we, of course, know that complementary angles add up to 90 degrees. So you can make this equation really quickly to find the value of x. Perfect. Okay. Now for the value of y. If I just tried to use this 2y minus 7 degree angle, there's no reason for me to know what that is equal to. However, let's use this other angle that it's adjacent with that also has a y in its measure. Those two angles form a special kind of angle pair, don't they? Those are a linear pair. And that linear pair postulate tells us that linear pairs are supplementary. Alright, so here's the equation that you ought to use to find the value of y. Alright, and then if you go about solving that, you'll end up with y is equal to 21. Alright, last variable in this picture is z, and that's the only angle that has a z in it. Now, there's two ways we can go about finding out the angle z's measure. But I want to make sure that you know that there's not another angle with z as part of its measure, so we're going to have to use substitution here. Either we can use this linear pair and say that 5z plus 6y plus 19 is 180, because linear pairs are supplementary. Or we could use the vertical angles right here, which have to be equal to one another. And that's a slightly easier equation, so I'm going to go with it. I'm going to set 5z equal to 2y minus 7, like so. Then we're going to substitute 21 for y, and you'll get 5z is equal to 42 minus 7, or 36. Oh, sorry, 35. And so z is equal to 7. Alright, that's using angle pair relationships. There's many more problems we can do. I think that's a good sampling for you though. Good luck with the problems in your assignment. I'll see you in class.